All right, this is the video explanation for the week 2 quiz. Now, as a quick note, please keep in mind that for many of these problems, your numbers may be different. For example, question 1 is a formula question, so you're going to get different velocities and different times than I will, but the process will be the same. So for question 1, and for all these problems, we are dealing with constant velocity, so delta x equals vt. If you tried doing it using your kinematics equations, then what you would be doing is getting delta x equals v naught t plus 1/2 at squared, because in every case, they never give you an acceleration. So if your acceleration is 0, then everything multiplied by that 0 would be 0 as well, and that entire term falls away, giving you the equation for constant velocity. So for problem 1, I have a car starts at the origin. Origin just means its initial position. Its x naught is 0 and moves away with a velocity of 16 meters per second. How far away will it be after 49 seconds? So this is just delta x equals v times t. And so in this case, with the numbers I have been given, it would be 16 times 49, which would be 784 meters. Now, again, different numbers, but to double check, just take this number, multiply it by this number, and you should be good to go. For question 2, graph below shows, and for question 3, really at the same time, position of the soccer player on the field during the final moments of a game. Okay, so the first thing to note here is this time here is 55 seconds. That's going to play an important role in question 3. So for question 2, it says, what is a soccer player's average velocity? Well, average velocity is displacement over time. And displacement is the difference between your starting position and your ending position. Well, we started at 0 meters, we ended at 0 meters, therefore your displacement is 0, your time is 55 seconds, but anything divided by 0 is 0. For the soccer player's average speed, it's the same idea, but instead of displacement, we use distance divided by time. So in this case, we have to actually go through and add up the total distance that the soccer player traveled. So they start here at 0 meters, they go up to 60 meters, so they traveled 60 meters here. Were at 60 and stayed at 60, so they did not go any distance here. They started at 60 and went all the way down to -40, so they went 100 meters here. And they started at -40 and went up to 0, so they went 40 meters here. Again, we don't care about directions here. So the distance is going to be 60 plus 100 plus 40 is 200 meters was the distance traveled in 55 seconds. Should give you an average speed of 3.64, I believe. 3.64 meters per second. Again, you don't need to include the units in fact, you should not include the units in the actual typing in, but it's a good habit to think in terms of units. All right, question 4. What is the velocity of a bicyclist that can travel 485 meters in 35 seconds? So again, we're dealing with delta x equals vt. So they're traveling 485 meters in 35 seconds. Again, your numbers may vary. We divide the 35 over, and 485 divided by 35 should give you 13.86 meters per second. But once again, please remember that these numbers will differ. So it's just 1 divided by 2 is essentially all you're doing there. All right, question 5. Again, numbers may vary, but train passes a train station traveling at 49 meters per second. So there's your velocity. The next station is 2,653 meters away. There's your displacement. And again, we're doing delta x equals VT. This is repetitive because you're watching this video straight through. I apologize, but some people will be jumping around. All right, so we're going to divide the 49 over. And again, for these specific numbers, and once again, your numbers may vary, so just do the same process with your numbers to double check your answer. But for my numbers, I got 54.14 meters, sorry, seconds. Seconds would be your units there. All right, question 6. Car starts the origin, moves with velocity of 5 meters per second, 51 meters per second, sorry. How far from the origin will the car be after traveling at 62 seconds? Again, the origin just means how far from your starting position. It doesn't mean anything important. Again, your numbers may vary. They are random. Just do the same thing with your numbers to double check your answer. But in this case, we are given a velocity of 51 meters per second and a time of 62 seconds. So that means the car will have traveled a total of 51 times 62 or 3,162 meters from the origin. And question 7, not a random question, so everyone's answer will be the same here. It asks for the average speed during the time interval of 1 to 2 seconds. Well, again, just like with the soccer player, we have to ask ourselves its speed. So we are looking at distance, although in this case, because we're traveling in the same direction, distance and displacement will be the same thing. So at 1 second, we are over here at 2 meters. And at 2 seconds, we are over here at 8 meters. So we went from 8 or to 8 meters from 2 meters, which means we traveled a distance of 6 meters. And we did so in 1 second, an average speed. Don't forget is distance divided by time. So it's 6 meters divided by the 1 second because it was 1 to 2 seconds. This is an interval of 1 second. So 6 meters per second would be the correct answer. If you have any questions, please stop in during office hours, and Mr. Bartolomeo or myself will be happy to go over this with you. Thank you very much. Have a great day.